There were some requests for an additional video on vector addition in the hiker problem. So I'm going to see if this works. I'll do one on my whiteboard in my office here. Okay, so I'm going to just give you two initial vectors. I'll say that I start hiking at an angle of 30 degrees south of east for 5 kilometers. And then from here, I turn and I hike at an angle of 45 degrees north of east. So let's say from this point here, I turn and I go 45 degrees, and I have to measure this angle from the eastward direction, measured from that point, 45 degrees. And I'll say for this one, I go 8 kilometers. Okay, so my goal is to add those two vectors together. And the result I'll get, I'll draw in red right here. That's the resultant vector. Okay, so that's my sketch. Note the angle is drawn from the east direction, so it's 30 degrees south of east. And then I hike 45 degrees north of east. North is above, as measured from the second point here. And this is my home. And this is my destination. I want to find the length and the direction of that red arrow. So what I'm going to do now is I'm going to determine the x and the y components of each of these two vectors. This black vector there and that one there. I'll call this one R1. I'll call this one R2. So I'll say R1 right here is an x and a component and a y component. They're kilometers. And this is R2. I add them together to get R3. Okay, so R1x I'll do right here. It's equal to 5, that's the length of this vector, 5 kilometers, times the cosine of 30 degrees. Since that's the 30-degree angle right there, I'll erase this extra stuff right here. This is my 30-degree angle. The cosine is the adjacent side, and the sine is the y. It's the opposite side. It's going to be the y component of it. It's going to be 5 times the sine of 30 degrees. And it's going to be negative. I can put my negative in right there for the y direction because it's going downward from the initial home point that I'm walking. So I'm walking down here. That's positive in the x direction and negative in the y direction. So if I calculate this, this is 4.34 kilometers. And this one here is negative 2.5 kilometers. So I can put those two values in here. I have negative 2.5 kilometers in the y direction, and I have 4.34 kilometers in the x direction. Okay, so that's my R1. Now for R2, I think I'll erase what I wrote here so I have enough space to calculate R2. So I'll find R2x and R2y. R2x is equal to the length of the vector R2, that's 8 kilometers, times the cosine of 45 degrees. And it's positive. They're both positive, so I'll put my plus signs in there because it's going to the east, which is positive x, and it's going north, that's positive y. R2y is plus 8 sine 45 degrees. Okay, sine and cosine of 45 degrees is 0.707. And just to make sure I do it correctly, I'll calculate 8 times 0.707. And I get 5.66 kilometers. Okay, hopefully you can see that. I realize there's some glare. but I'll put those in here, plus 5.66 kilometers, plus 5.66 kilometers. Then I'll add up my R1 and R2. So I'm going to get on this one, 4.34 plus 5.66 gives me an even 10 kilometers. And then 5.66 minus 2.5 gives me a plus 3.16 kilometers. Erase this here. Okay, so this plus 10 kilometers and this plus 3.16 kilometers, represent the x and the y components of my final vector, the red vector. Okay, so if I want to find the length of R3, that's how far I'd have to walk, or the sum of the length of the sum of the vector, of the two vectors. I would take the square root of the sum of the squares of 10 kilometers, so I'm going to square 10 kilometers. I'm going to add to that 3.16 kilometers squared. Take the square root of that, which it's about 112. So if I take the square root of 112, I get about 10.6 kilometers. That's how far I have to walk. Now the direction I have to walk is given by the angle between this red axis and the eastward direction, and you can find it by taking the inverse tangent of the y, the opposite side, 3.16, divided by 10. I take the inverse tangent of this one, divided by this one, and that's going to give me an angle, and I'll calculate it. Gives me 17.5 degrees. And the angle, as you can see here, this is the eastward direction from my original starting point, my home, and I'm going north of east. So that's the angle I would walk. So my final answer is I'd walk a distance of 10.6 kilometers at an angle of 17.5 degrees north of east. So I hope this is helpful to you for those who want to see additional practice on vectors.